Hello and welcome back to Voyageurs National Park Association's Night Sky Explorer series. We're here again with Astro Bob King, and the good news is that we are going to be continuing this Night Explorer series throughout the summer. We'll be switching to every other week. So 2 weeks from today, we'll be back again with Astro Bob. Just a couple of introductory comments as we get started. We like to know where you're watching from, so go ahead, give us a shout out in the comment section of where you're watching from. We will also be posting different links there when Astro Bob discusses them, so you can go there for more information. And any questions you have, go ahead and type your questions in the box. We'll have plenty of time for a question and answer at the end. So I'll go ahead and introduce once again Astro Bob, that he has, that he fell in love with astronomy and the night sky as a child, and he enjoys sharing that information and passion with people of all ages. He is a photographer for the Duluth News Tribune for 39 years, retiring as a photo editor in 2018. He's taught at Duluth Planetarium and written 3 books, has his own blog, and is a regular presenter here at the Voyageurs National Park Association. So welcome, Astro Bob.
Thank you very, very much, Jackie. I appreciate that. Welcome back, everybody. Good to see you all out there in the giant world of the Earth, one of only 8 planets. Well, 8 planets in our solar system. Of course, there's a few thousand exoplanets that we know of that orbit other stars. I wanted to start off this week with information about a new star chart that just came out. Remember, in our first week, we talked about going to skymaps.com. Well, that was in April. My gosh, it's May already, which means the mosquitoes won't be too far behind. And here we have the May sky map that's available for free download at skymaps.com, along with a list of events throughout the month that you can check out, most of them being naked eye, no equipment needed. Also wanted to alert you to our phone app. We talked about this last week. Here it is again. You can see it there. I've got it activated, so wherever I point it, it shows what's up in the sky. A little thing I wanted to acquaint you with about the phone, and maybe you've already tried this. This is really fun. Have you pointed it at the ground yet? Now, you may think that's not intuitive, but if you take your phone with that app and you point it downward, oh my gosh, it sees right through the Earth, and it will show you the constellations that are not up, plus the constellations of the Southern Hemisphere. So if you've never seen the Southern Cross, just point your phone at the ground, and people may think it looks a bit peculiar, but you can tell them you're just getting the Earth out of the way so that you could view the night sky from below the equator. That's a lot of fun. So this week we're going to talk about, we have 2 topics. The first one being the full moon. And for that, we're going to take you to a few views of the full moon right now. Hold on just a moment. And here's our night sky app that we just talked about. My gosh, this week, at least for this part of Minnesota, our region here, it's been a great week for flowers to make their first appearance. And I was out about 4 or 5 days ago in Jay Cook State Park and came across this beautiful patch of bloodroot flowers. We also look down at the ground and in the sky because all of it is nature, right? So the full moon, which occurs this week, is sort of in the spirit of spring, because it's not just any old full moon. This is the full flower moon. That's its traditional name. So that syncs very nicely, at least with the current flowers of spring. Now, I've got the full flower moon listed as happening on 2 nights, May 6th and 7th. And that's because the moon will actually be full on the morning of the 7th, but it'll be daytime and you won't see the moon. So you can look at the moon the night before, when it'll be about 99.5% full. And you can also look at it on the day after, on Thursday, the 7th, when it'll be 99.2% full. So basically full to your eye. You only can see, but it's not full if you're using a telescope or maybe a powerful pair of binoculars. The full moon is located in the constellation of Libra. And to the upper right of the moon, we touched on these a little bit, there is a special figure called the spring triangle. Those figures, you might remember, we call them asterisms. There it is right there. It's made of Spica, which is the brightest star in Virgo, and that'll be off to the right of the moon. Way up above Spica, if you reach your fists up to the sky and mark 3 fists against the sky, you'll see Arcturus. That's the brightest of these 3 stars. And then swing on over to the right and hook in Denebula, which is the tail of Leo the lion. Connect them all, 3 fists on a side, and you've got the spring triangle. Very nice. Now the full moon, and we touched on this, I believe, a week ago, the full moon and the moon's phases occur because the moon revolves around the earth and its angle changes with respect to the earth and the sun. So we see different amounts of it illuminated. Full moon is a special time. Here in our diagram, we can see the sun off to the right. The sun shines past the earth and directly on the opposite side of the earth illuminates the face of the moon. And from our perspective on the ground, because the sun is directly over our shoulders, it lights up the entire face of the moon. So the moon is full. It's directly opposite the sun on the other side of the earth. Now you might wonder, well, Bob, what's the deal here? If these 3 bodies, sun, earth, and moon, are all in line, why don't we see a total eclipse of the moon? Why doesn't the moon over here go into Earth's shadow, the big shadow that our planet casts? The reason is because the moon's orbit is tipped slightly, so that it normally, most months of the year, most full moons, normally misses the shadow of the Earth. It's either up here or it's down below here. So it misses that shadow. But a couple of times a year, bam, it hits it directly. And then we do see a total lunar eclipse, which only will occur, of course, at a full moon. Look at that. This is from Lake Superior. Picture of the moon. It's all gummed up looking because I captured the moon at the moment really, or just a few moments into its rising. Sometimes you may have seen this too. And as a matter of fact, the reason why full moons are so exciting to watch is because they just look spectacular, especially if you can see them at the moment of rising. And if you're near a lake or if you happen to have a big field near where you live, go there, look to the east and watch for that moon to rise on May 6th and even more so on May 7th because it'll rise in a dark sky on May 7th. Easier to see at rising time. When the moon first comes up, if you can actually see it right at the horizon, as you see in this picture, you're actually not even seeing the real moon. It is an optical illusion, and it's caused by Earth's atmosphere, the very air that you breathe. Here's this diagram where you can kind of get an idea of what's happening. The air is very, very thick when you look through it at the horizontal. When you look towards the horizon, you're looking through the bottom of the atmosphere where the air is very dense. And that dense air acts like a prism, and it literally bends the light of the moon, which is over here. It bends the moon, which is still below the horizon, upward into view above the horizon. So when the moon is just sitting there right on the horizon, it actually hasn't risen. It's not there yet. If you could magically snap your fingers and remove the atmosphere, the moon would disappear below the horizon. Jackie, can you bring me back? Here's, I just wanted to show you, I love prisms. And a prism takes light, comes in this side, and it bends the light and comes out at a different angle on the other side. Now, a prism is made out of glass, but the atmosphere is made out of air, but the air is that thick that it acts like a prism, and just like a prism, it bends the light of the moon, causing it to lift up. It also does something else really cool. Besides lifting the moon up above the horizon when it's not even there yet, it lifts the bottom of the moon a little bit more than the top because the air at the very bottom is thicker than the air just a little bit above it. And so it literally to your eye, it crushes the bottom part of the moon into the top part of the moon. And when you do that, when you push the bottom into the top, this is what you get. And I'm going to take you back for a photo of that. There it is. Does that look familiar? Look at that, like somebody sat on the moon. Wonderful. It's like a watermelon or something. And that's because the air down here is thicker than the air even up here. And so it refracts or bends the light upward. So the moon gets squished. Look at here on the right. By the time the moon gets high enough in the sky, it loses that squished egg-like shape and it turns back into a circle, because by the time it's up high, you're looking through a lot less air. And so that has very little effect on bending the moon's light compared to the air near the horizon. Here's the other thing you'll notice when you go out, whether it be Wednesday, tomorrow night, the 6th, or Thursday, the 7th, to watch the double full moon rise. You'll see that the moon is very orange or red when it's near the horizon, and it gradually yellows and then whitens as it rises higher and higher. Once again, what's behind this? The air itself. The molecules of the air, the oxygen molecules and the nitrogen molecules, these little atomic things scatter the blue and the purple coming from the light of the moon. Remember, the light of the moon is of all colors. White light is in all colors of the rainbow. But the molecules redirect, push away all of the little blues and the oranges, or blues and purples. And that is what gives the sky its blue color during the daytime. So it scatters those colors away. And what remains when you scatter away all of those deep blues and purples is red, orange, yellow, a little green. And that's why the moon comes up so red and orange, because the molecules have scattered away the cooler colors. And only the longer wavelength lights, the reds and the oranges, penetrate the atmosphere and make it to your eye. Who of you has noticed the moon looking gigantic when it rises? Who hasn't, right? Most of us, when we see a full moon rise, we'll see how apparently how big it is. It looks gigantic near the horizon, and it looks much smaller when it's overhead. And there's a good reason for that happening. Well, there are reasons for it happening, and some we don't fully understand. Obviously, the moon's not changing size, right? It's not bigger at the horizon. It's smaller overhead. It's the same distance from us, give or take a few miles. What happens, though, is we are seeing the moon in different contexts, is the way I could put it. When it's near the horizon and we see objects around it, like trees and buildings, so forth, the moon looks large compared to those objects. And I'm going to show you, this is the moon with small objects around it, like houses and trees. In the context of smaller earthly things, the moon looks bigger compared to the same moon up here when it's much higher in the sky and surrounded by giant chunks of sky. That's what these circles represent, big pieces of sky. Can you see that illusion? Does this bottom moon look bigger to you than the top moon? If it does, then you're seeing the moon illusion here, simplified. It's also called the Ebbinghaus illusion. I think one of the most enjoyable aspects of moon watching, especially full moon watching, is to see faces and shapes in the moon. We are a pattern-making species. We talked about that, didn't we? We talked about constellations, how the ancient peoples, the shepherds, the mariners, these people made the constellations and imbued them with stories and myths. Well, we do the same with the moon. You might look up and see over here on the right, these dark areas represent eyes and a nose and a mouth. This is quite an artistic view. I don't think I've ever gone off that far. I can only maybe see a couple of eyes, a nose, and a mouth. But other cultures see other things. Here is a person walking, carrying a load of wood. And over on the right, this little dark area, which you see over here, this little dark area is a dog following. Down here, we see the rabbit in the moon, like so. made out of the dark and the light. And over here is a woman in the moon with a rather old-fashioned 1940-ish hairstyle. And the crater Tycho is her amulet. So these dark and light areas of the moon, we assemble into patterns. What are those exactly? Here's a photograph of the moon so you can see them more clearly. The bright white chunks of the moon that you see with your eye, those are called the lunar highlands. These are cratered areas, just saturated in craters. They are the original ancient crust of the moon that's over 4 billion years old. And it carries the record of every single asteroid and meteorite strike in the form of those craters. Just, they're spectacular in a telescope, even in binoculars. These areas here are called seas or basins, right? Like that. There's this, here's one right here, the Sea of Serenity. Here is the Sea of Tranquility where the Apollo 11 spacecraft landed. These seas, if you notice, are round. Look at this. That looks like a giant round crater almost. These are what we use to make the eyes of the man in the moon. Or we use them to make the rabbit's ears, whatever your choice is. These seas are actually gigantic impact scars from asteroids that struck the moon after the lunar highlands or the ancient crust formed. And they filled in with lava. And that's what you see right to today, right up till today. These are lava-filled impact scars that are younger than the ancient highlands. So they don't have as many craters in them, which is why they're smoother and darker in appearance. This is what it looked like. I took a picture in time. A picture of the moon back when it was being slammed up and down by meteorites and asteroids, all the bodies of the early solar system. It was constantly under bombardment until either this material was absorbed by those bodies or it was ejected from the solar system. When you look up at the moon, how big is it? Huh? Look at that thing up there, that sphere. Well, it's 2,160 miles across. And just for quick reference, it's about as big as the United States, actually a little shy. It's the United States, the continental, from end to end is about 2,800 miles, give or take. So the moon's a little bit smaller than the continental United States. Oh, look at this. Just imagine walking on the moon. This is from one of the Apollo missions, Apollo 17, I believe. There's an astronaut there walking. I mean, it's totally desolate, isn't it? It's frighteningly so in a sense, and yet it's still beautiful to us. There is a beauty there that makes me, and maybe some of you, would love to get there someday, to be an astronaut, to walk on another world, as 12 people already have. Just spectacular. Notice there's nothing in the sky. What's going on? You're like, well, wait a second, shouldn't there be some stars there? The reason, and maybe some of you can guess why, but the reason why there are no stars is because it is as bright and sunny on the moon as it is on the Earth, because we're the same distance from the sun. So when you take a picture and you expose it for a sunny daytime landscape, you are not going to record any stars in your picture at all. You have to do a time exposure for that. So if you did a time exposure, then you would show the stars, and then the landscape would be totally blown out and overexposed. So you get one or the other, but you can't have both. Can you take me back, Jackie? Hello again. Here I am. There is a human behind here, behind those pictures. I hope you enjoyed our look at the full flower moon. Again, I've got a blog on this. You can go to Astro Bob. Just type in Astro Bob and Google it. And I've got a blog about some of the other things that you can see during this week's May flower moon. And I hope you see some flowers too, for that matter. I have something here I'd like to talk about. We want to talk about comets next. And that's one of the reasons why I wear a green shirt. It's because maybe you've seen photographs of comets, but they often look green in color, especially the head of the comet, which is fluorescing gases. And they fluoresce this most beautiful kind of Mediterranean green. Sometimes they're bright enough to see that way in a telescope. we have one very nice comet coming. I am certain you'll see it in a pair of binoculars if you can find a reasonably dark sky sight. And you might, some of you might just be able to see it with the naked eye. It should have a pretty tail too. So we're going to switch over so I can tell you a little bit about this beautiful comet coming. There it is. Oh, look at that. Oh, look at that tail. Oh my gosh. Giant. That's called Comet Swan. And swan is an acronym. It doesn't actually mean a swan, but you know, I like the elegant sound of calling a comet a swan. They are graceful in their ways. This is named after a camera aboard a solar observatory in orbit around the Earth. And that's an acronym for the camera. Who discovered this comet? Well, it was found on March the 25th by this guy, an Australian amateur astronomer named Michael Matiaso. And he found it, oddly enough, or maybe not surprisingly, because he was stuck home from work because of the COVID-19 virus. So while he was home, he went to a public website for that solar observatory, and he just was browsing through the daily images that it takes. In browsing, he discovered a fuzzy spot, and that fuzzy spot turned out to be Comet Swan. It was not that bright at first back in March, but it's brightened rapidly. It's grown a tail, and it will soon be in our evening sky here, starting about the the second week of May, so in about a week. Here is an animation of the comet where you can see the comet's head. These are the basic part. This is the comet head, big glowy ball in front. And this is the comet's tail. Look at the beautiful structure, and it's changing too. This was just taken in one night, and you can see the gases streaming away from the head of the comet. Now, I want to alert you that comets may look sort of like meteors, and you might think it's just there and gone, but comets are actually very far away from the Earth, many millions of miles, and they are not in our atmosphere, and they are moving around the sun. And so they might appear like meteors, but a comet moves around the sun kind of like a planet. So it moves bit by bit by bit each night, and it can be visible up to months, many months. You saw the head of the comet. What's making all that glow? What makes the tail of a comet? Well, it comes right down to just this little tiny nugget. I guess it's not that tiny, right? 6.8 miles across. This is a picture close up of Halley's Comet. So it's only about 6.8 miles. And this is on the larger side. Many comets are only about a half a mile across, maybe a mile, mile and a half. They're small, and they are made up predominantly of different kinds of ices. Water ice, dry ice, which is carbon dioxide ice, methane, ammonia. Some have amino acids in them, all kinds of interesting things, but primarily ice. And impregnated in the ice, stuck in there, are billions of bits of dust, little pieces of rock, things like that, bits of gravel. So when a comet approaches the sun, the heat from the sun begins to vaporize that ice. And along with the vaporized ice goes the dust. And the heat, I should say the light, pardon me, the light from the sun pushes the dust back. Here you can see right there, pushes the dust back to form a tail. Sunlight, and it's an amazing thing, actually has pressure. It can push against things like dust particles, and it pushes them, and that's what creates the tail. And the tail, being made of dust, reflects sunlight. So it has a pale yellow appearance. Many comets get a second tail, the blue one. This is called the ion tail, and that's caused by gases that fluoresce in the sun's ultraviolet light. So you get two tails, you've got a bright head of the comet, and right in the middle of it all, of course, is the nucleus. That's the core, that's what it's called. You saw the nucleus of Halley. This is the nucleus of another comet called Hartley 2. This photograph was taken by a visiting spacecraft back in 2010 from just 420 miles away. Hey, check it out. Watch out. You might get hit in the face. Thankfully, it did not damage the spacecraft. But this thing is shooting out jets of material. Can you see these beautiful jets? These little balls are actually made out of soft, fluffy water ice, and they're about the size of basketballs or something, and they're just being blasted out of the comet as it's struck by sunlight, as it vaporizes. And that goes to create the tail and all the beautiful phenomena that go with a comet. Where is this thing? Well, it has 2 times when it's visible. Early on, we will see Comet Swan at dawn. So that means you will need to find a place where you can get down as close as possible to the eastern horizon. Unfortunately, this comet will never get super high up from the horizon. It'll always be kind of down low. So you need a nice open spot about an hour and a half before the sun rises. And I made this map, and we'll have a link for you so you can check this map out yourself and download it if you like. And it shows the comet from May 6th. It'd be very difficult to see it from the northern United States then, but you can see it from the southern states. But watch as it moves from May 6th, May 9th. See, it's tracking to the left or to the east. May 12th, up here to May 15th, it enters this little constellation called Triangulum. May 18th, and so on. All of this action happens beneath a familiar asterism in the sky belonging to the constellation of Pegasus the Flying Horse called the Great Square. So if you can find the Great Square and you bring out your pair of binoculars an hour and a half before sunrise, look down low in the east, start at this star, drop down, you hopefully will be able to see the comet. And this is again at dawn. Now, this will be the better view of the comet. Thankfully so, because it's in the evening. I don't know about you, but I'm not real big about getting up at 4 a.m. I will do it. I'll see any comet at 4 a.m. if that's when it wants to meet me. But it's a lot easier in the evening. This is Comet Swan, late evening twilight, May 22nd through June 9th. For this, you're going to need, similarly, you're going to need a nice view low in the northern sky. And I have put positions in for May 22nd. Look at how much it moves in those 3 days. It starts slowing down here. May 31st, June 3rd, 6th, and 9th. Thank goodness we will have a good marker star, the star Capella. Very bright. It'll be the only bright star twinkling away low in the northwestern northern evening sky. So look for this star, use this map, and we're going to get you there. I have one more comet observation to make. We had another comet that was coming, and it was supposed to be bright in May too. However, it busted apart. Those jets that you saw shooting out of the comet that looked like geysers earlier, those things push, and they have some pressure. They push against the comet, and they shoot off in all directions. So astronomers think that that pushing maybe spun up the comet or maybe battered it in a way. They're fragile. They may be made out of ice, but it's kind of a honeycomb-like ice, and they're fragile, and they can be broken apart. And Comet Atlas busted to pieces just on the verge of when we thought it was going to be bright. So unexpected and wonderful things can happen to comets. And Jackie, you can take me back. Hello again. So we have Comet Swan that'll be visible, and that's still about 2 weeks away when we'll really start to see it. And I promise on my website, I will make regular maps for you so that you'll be able to track it easily. And I'll have some photographs too to pair with those maps, assuming it's clear so I can take a picture. But I have some photographs to pair with those maps so that you can go, oh, okay, I look for this, and then I go there, and then I go there. Okay, then I can find the comet, because I'd really love for you to see this comet. It's been some years since we've had a bright one, and this has promise. So with that, that's the end of my presentation. If you guys have any questions, I'm here to answer. And if you don't, I have some show and tell for you too, but I'll wait for a question. And I think we did have a question about what telescope I used. Was that right?
If you have any questions, go ahead and type them in the comments.
Someone did ask me last time, and some reason we didn't get to it, but they asked me what telescope do I use I use several different telescopes. When it comes to finding a bright comet, the first thing I'll always grab is a pair of binoculars because they're just so handy. They're much easier to point and look at something. If it's bright enough, you can get it in the view, focus it, and see it clearly. Binoculars have a really nice big picture window, so they make finding things like brighter comets pretty easy. Then when I want to hone in, I've got several different scopes. My largest one is 15 inches in diameter. The mirror is 15 inches wide, about that wide, and it weighs about 57 pounds, and I have to put it together every time I use it, but it's well worth it because it shows just spectacular views of nebulas and galaxies. And also I can get right inside that comet head and sometimes see some fascinating things happening. Sometimes you can even see some of those jets that you saw in the photograph of Comet Hartley and Comet Halley.
We have a question that's come in asking how many years since the last bright comet?
Well, the last really bright one where you could just go out and look at it like right there hanging in the sky. Some of you may have heard of this comet. It was called Hale-Bopp. Comet Hale-Bopp, discovered by Alan Hale, two guys, Alan Hale and Thomas Bopp. Surely one of the greatest name combinations ever for a comet. And that was back in 1996 and 1997. That one was super bright. That was the last bright, truly bright comet. Sort of bright comet that you could faintly see with your naked eye was Comet Wirtanen, and that was visible about 2 years ago, back in the wintertime. It didn't have a tail, but you could see it very easily in binoculars, even from suburban areas. So it's been a few years since we've had a comet where you could go, hey, look, I can see this in binoculars.
I don't see any other questions coming in, so it'd be great to have you do a little bit of show and tell, Bob.
Very good. I'm happy to do. Show and tell is still my favorite thing. I have not changed since I was 6 years old. You saw that stuff coming out of the comet, right? All that material, that dust and all the ice and so forth. That material ultimately becomes our meteors that we see in the sky. Virtually, not all, but many of the meteors that you see streaking across the sky are actually fragments of comets, and especially meteor showers. That's where we actually slice right through the orbit of the comet, and we pass through its debris trail, and that stuff slams into the atmosphere as meteors. That's all tiny stuff, vaporizes, right? But occasionally you'll see a really super bright meteor, and large ones come from asteroids, rocky ones that can actually make it through the atmosphere. So I've got a couple of meteorites here to show you. Here's just a beauty. Look at that. Oh, it's got those beautiful thumbprints right there all over the place. Those are called regmaglyphs. This particular meteorite is very heavy for me to hold. It's made out of iron and nickel, little carbon in there too, and a few other elements. This one fell, we estimate, maybe 5,000 years ago in Argentina, southern Argentina, at a place called Campo del Cielo. So this is the Campo del Cielo meteorite. And man, it's heavy, iron nickel. Similar meteorite. This is also from an asteroid, but a different asteroid. You can see the surface of this and how it reflects the light beautifully. It looks really kind of cruddy on the outside, rusty. Because meteorites rust, by the way. They don't last very long at all. They rust and flake away. But this one is cut, and after it was cut, I etched it with acid, and you can see the beautiful structure there. Look at that pattern. And that pattern only happens in meteorites. That tells you immediately you have a rock from outer space right there. Couple more. Do you guys remember the big fireball and all the videos the dash cam videos. Let's see if I can get this. I got to bring it in close. All the dash cam videos from Russia back in February 2013. The Chelyabinsk meteorite, which was about 5 stories tall before it hit the atmosphere, came flying in at many thousand miles an hour, and it was ruptured. It just blasted into thousands of bits, and those were roasted on the outside as it passed through the air, landed on the ground, right into the snow. And this is one of those pieces from that fireball. That was the famous one that shattered all the windows, and many people were injured because of flying glass, because they saw the light, went to the window, looked, and the thing blew up. Or the shock wave from the explosion blew up the glass. And I have one last one. It's very interesting. This is a meteorite that was found in the Sahara Desert, and it's actually a piece of an asteroid. We know the actual asteroid this came from, and the asteroid is called Vesta. And you might wonder, well, how do we know? But this came from that asteroid. Well, we actually went to Vesta in a spacecraft. NASA launched the Dawn spacecraft, which orbited Vesta, studied the minerals in the surface from orbit. Turned out it was an exact match for particular kinds of meteorites that have been landing on the Earth for centuries. So this is a slice of an actual asteroid that we can say, yep, Vesta here. So those are just a little bit of my show and tell. I always like sharing meteorites because it's one of the few things in astronomy you can actually touch. Do you guys have any other questions?
We have one more question before we wrap up today. The question is, I assume the comet maps will be helpful for us in the southern part of New Mexico too. Is that correct?
Yes, I won't make specific maps for southern, was it New Mexico? Southern New Mexico. But
Yes.
I will, the maps will be set for the central United States. And so the view in southern New Mexico, for the evening sky, the comet will be a little bit lower than what you'll see in the map. And it will be a little bit higher than what you see in the morning map. So you guys are favored for the dawn view in southern New Mexico. However, not quite as favored for the evening view. So try them both though. The comet will be in the same position in the sky in relation to the stars. So the map is useful that way. It's just that the altitude of the comet will be a little different morning and evening for you versus for me, for instance, in northern Minnesota.
Thank you, Astro Bob. So we will continue this again in 2 weeks from today on May 19th. And I'm putting up here the webpage so you can find out more information from Astro Bob on his blog, as well as go to our voyagers.org website for more on dark skies. Thank you for watching, and thank you, Astro Bob.
Thank you.